Today we have to discuss about Newton's rings. Okay, so the one of the scientist Newton, he formed the interference pattern in the form of rings, or you have to call it as a fringes, and he used the one of the plano-convex lens. This one is the plano-convex lens, and it is having a long focal length. Okay, the focal length is very long of this lens, and you have to kept this plano-convex lens on a thin glass plate. This one is the G is the glass plate, L is the plano-convex lens, and he the in between the glass plate and plano-convex lens there is a thin film formed. That thin film you have to call it as a air film. Okay, if the empty space is filled with the air, and that one you have to call it as a air film, and the air film at the middle it is very thin. Okay, so at the point C it is very thin, and gradually it is goes on increasing. The thickness gradually goes on increases, and due to the air film, so when the monochromatic light incident on this plano-convex lens, the circular fringes are formed. And these fringes are, one fringe is dark, another fringe is bright. One fringe is bright, another fringe is dark, and these fringes having a uniform thickness. The all fringes having a uniform thickness. When you have to viewed with a white light, and that time bright and dark circular fringes are produced in the air film. Okay, and now we have to study about the construction of this Newton's rings experiment. So you have to consider S is the source of light. Okay, it produces the monochromatic light, which is placed at the principal axis of this lens L1, and a horizontal beam of light falls on a glass plate. We have to place it at a 45 degree, and this glass plate you have to denote it as a B, and when the horizontal beam of light placed on the glass plate, it will be completely reflected towards the plano-convex lens. Okay, so the completely reflected towards the plano-convex lens or towards thin air film having a glass G and a lens L. Okay, when it will be incident on this plano-convex lens, and it will be reflected back, towards the microscope M, and in this microscope we are observing the uniform circular bright and dark fringes, and this is nothing but a interference pattern. Will be observed on the microscope. This pattern will be formed. The incident light will be reflected from the upper surface of the lens and upper surface and lower surface of the lens. It will be reflected from upper and lower surface of the lens. Due to this reflection, the interference pattern will be formed. Okay, this is general construction of the Newton's rings. Now we have to discuss about the theory of Newton's rings by reflected light. Okay, now you have to consider vertical section of the plano-convex lens. That vertical section you have to take it as A, C, B, E of a convex lens, and here you have to take a R. R is the radius of curvature of this lens from this center of point. R is the radius of curvature of the point, and C be the point of contact curved surface with a plain glass plate. curved surface with a plain glass plate, such that AB is the equidistant point from the C. Equidistant points from the C. Next you have to draw A dash, and you have to draw B dash, perpendicular to the plane, A dash, B dash. Now let A dash, this A dash and B dash having a thickness T. This is having a thickness T, and it is having a distance R from the point of contact C. From point of the contact C, the B having R distance, and D to A also having a distance same R. And now you have to take the geometry of the circle. So the total geometry of the circle, you have to consider DE and DC on this side and this side, AD and DB. So you have to take DE into CD equal to AD into DB. Here DE and DC, here AD and DB. Here you have to take on. So DE, here total length is EC minus DC ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ DE. ಅದನ್ನ ಏನು ತಗೊಂಡಿವು CE minus CD, D ನ CE minus CD into CD as it is equal to AD square. AD square ಯಾಕೆ ತಗೊಂಡ್ವಿ ಅಂದರೆ AD is equal to the DB. Therefore, because AD is equal to DB, so you have to take a AD square. So CE minus CD. So CE is the total from here to here. So the half is R, here half is R. So R plus R is 2R minus T. So into CD is T equal to R square, AD square. So AD DB, R into R square. You got here. Where R is the radius of the ring, and radius of the curvature R of the lens is very large as compared to the thickness of the film. Okay, if you consider thickness with the radius, it is very small. From the above equation, 2RT minus T into T, you have to multiply T on inside. So 2RT minus T square equal to R square, as T square is very very small and neglect. Here T square is very small compared to the capital R, so you have to neglect that one. So 2RT as it is, T square is neglected, equal to R square. So here in the bracket AB by 2, so R square. So R square is here, R into R is R square. So total length is AB. So that one you have to take AB by 2 whole square. So this one you have to consider as a diameter of the ring, equal to D by 2 whole square equal to D square divided by 2 square is 4. So where D is diameter of ring, so therefore 2T equal to D square divided by 4R. So here 2RT is there, so we have sent this R on this side. At that time 2T is remaining, equal to D square divided by this R comes here, so 4R. This is equation number 1. The path difference between two reflected rays, one from A and other from A dash. So the two rays are reflected from, one is from A upper surface, another one from A dash from the lower surface. So already you got the path difference from the reflected light. So that equation you have to consider here, 2nt cos theta, where theta is angle of reflection. Here, since the ray reflected at A dash or B dash at lower surface of the lens, the medium surface suffers a phase change of phi, so increase in path by lambda by 2. So when it is reflected from the A dash B dash, at that time there is a phase change phi. So increase in path, so phase change alaga aವಾಗ path lambda by 2 increase ಆಗುತ್ತೆ. So So you have to add lambda by 2 to this path difference. So the effective path is 2t cos theta plus lambda by 2. So 2t here you have to consider 2t cos theta plus lambda by 2. Here n for here the refractive index 1 ಐತಿ. Here the refractive index 1 ಐತಿ. So ಅದಕ್ಕೆ n ಬಿಟ್ಟಾರ. So 2t cos theta plus lambda by 2. Thus the point A and B will lie on a bright rings. So the points A and B will lie on a bright rings. At that time 2t cos theta plus lambda by 2. So you know that the bright fringes gives the m lambda. So 2t cos theta equal to, so if you send lambda by 2 on this side, take a common lambda by 2. At that time you got the value 2m minus lambda by 2. For example, m lambda, you take this lambda by 2 on this side minus lambda by 2. So you have to take a common lambda by 2 here. At that time this term will be 2m minus 1, and this term here only 1 is remaining. Lambda by 2 is the common. Next I have to consider here, since the incident rays are normal to the surface, at that time the angle theta equal to 0. So therefore 2t equal to 2m minus 1 lambda by 2. Here we got the equation 2t cos theta. So theta equal to 0, at that time this is cos 0. Cos 0 is 1. So remaining term is therefore 2t equal to 2m minus 1 lambda by 2. This is equation number 2. Substitute value of 2t in equation number 1. So you know that equation number 1 we got here 2t equal to d square divided by 4r. Now we'll get here, so you have to put the 2t value in equation number 1. 2t equal to d square divided by 4r. D square divided by 4r equal to 2t value is 2m minus 1 lambda by 2. So next d square, this d square as it is equal to, so 2m minus 1. So you send 4r on this side. At that time 2 2's are cancelled, 2 lambda r. So d equal to square root of 2m minus 1 2r lambda. This is equation number 3. So how we got the square? If you send this square on this side, at that time we got the square root. As r and lambda are constant here, r and lambda are constant, so that this dm is directly proportional to m minus 1. M has values 1 2 3 for first, second and third rings or third rings. Thus diameter of bright fringes proportional to the square root of odd natural numbers. Okay, so this diameter of the rings is directly proportional to the square root of odd natural numbers. Odd natural numbers ಯಾಕಂತಪ್ಪ ಅಂತಂದ್ರೆ, if you put here first ring on this, at that time 2m, so 2 into 1 is 2 minus 1 is 1. If you put 2 here, 2 into 2 4 minus 1, you got the 3. So if you substituted any fringe number here, at that time you will got the odd natural numbers. For this is for the bright fringes. So for dark fringes, the path difference you have to take 2m plus 1 lambda by 2. So here 2t equal to m lambda, where m equal to 1 2 3 for dark rings. So already maximum and minimum condition for the reflected rays, we found out the value of this one. So next d square divided by 4r equal to 2t value is m lambda. So d equal to square root of, here you send 4r on this side, so square root of 4m lambda bar, you got the equation number 4. So d is directly for square root of m, where you put m equal to 1 2 3. Thus the diameter of the dark rings are proportional to the square root of natural numbers. So you got the natural numbers 1 2 3 as it is. For dark fringes, bright fringes you got the odd natural numbers, but in the bright fringes you got the natural numbers. Okay, this is the derivation for the Newton's rings by reflected light, or it is about theory of the Newton's rings, and this is important for the 10 marks. Okay, thank you.